On May 16, 1940, William Knudsen sat in his office at General Motors headquarters in Detroit, studying a telegram from Washington that left him in shock. President Roosevelt had just delivered an address to Congress proposing an ambitious goal: the United States needed to produce 50,000 military aircraft annually. As president of General Motors Corporation, which was the largest manufacturing company on Earth, Knudsen oversaw over 200 plants and 350,000 employees. His annual salary of more than $300,000 made him the highest paid corporate executive in America at that time. With 37 years of experience in manufacturing, he was well versed in cars, factories, and production lines. He grasped what Roosevelt truly required: for American industry to ramp up war production on an unprecedented scale. In 1939, the United States had produced fewer than 3,000 military aircraft, with a total of only 700 planes in the Army Air Corps, many of which were outdated. Now Roosevelt was calling for the capacity to produce 50,000 planes per year, an amount that exceeded the number of aircraft built since the Wright brothers' first flight at Kitty Hawk in 1903. The implications were enormous. If the United States truly required such a vast number of aircraft, it signified that war was imminent. Knudsen understood that once the conflict began, his life would undergo a complete transformation. Within 2 weeks, Roosevelt personally approached him and requested he leave General Motors to join the effort in Washington, tasked with organizing America's industrial mobilization. Knudsen accepted the offer without hesitation. It was May 1940, a time when France was disintegrating, Belgium had fallen, and the Netherlands had been overrun by Hitler's advancing armies, which were now threatening Paris and the English Channel. Britain stood alone against the Axis powers, and Roosevelt called on American industry to produce an air force surpassing any previously conceived scale. However, many doubted its feasibility, particularly in Berlin, where Adolf Hitler listened to Roosevelt's speech with amused disdain. His advisers dismissed it as nothing more than propaganda intended to intimidate Germany and bolster Allied spirits. German intelligence compiled a report assessing America's industrial capabilities and concluded that the nation could not produce 50,000 aircraft annually. The projection was based on American production figures from 1939, which amounted to fewer than 3,000 planes, with even maximum effort only expected to reach around 10,000 planes by 1942. To the Germans, Roosevelt's claim of 50,000 aircraft was seen as an unrealistic fantasy. The Air Ministry in Germany possessed comprehensive data regarding American factories. They were well informed about Boeing, Douglas, Lockheed, and Consolidated. These companies produced aircraft individually through manual assembly techniques, with skilled workers meticulously crafting each plane one by one. There was no use of assembly lines for the manufacture of airplanes. In contrast, automobiles could be mass-produced due to more straightforward manufacturing processes. The intricacies involved in constructing military aircraft were too demanding, necessitating high precision and specialized materials that could not easily be replicated on a large scale. A German intelligence report issued in June 1940 concluded that Roosevelt's speech was merely a bluff aimed at deterring further aggression from Germany. According to the analysis, American industry did not possess the necessary machine tools, skilled labor force, engineering expertise, or raw materials to produce more than 15,000 aircraft annually even under ideal conditions. The experts were convinced that America was far from being a military powerhouse. It was primarily an agricultural and automotive manufacturing nation with no experience in large-scale industrial warfare. The United States lacked a modern army, strategic air force, and had never undertaken extensive weapons production on an industrial scale. German strategists estimated that it would take the U.S. at least 4 years to establish the required infrastructure for significant military output. By then, they believed Germany would have secured control over Europe, rendering any American intervention obsolete. Hermann Göring, commander of the Luftwaffe, bolstered Hitler's confidence in this assessment. He told Hitler that while Americans excelled at building high-quality refrigerators and automobiles, Manufacturing complex military aircraft required a level of precision engineering expertise that was uniquely German. The Americans were deemed insufficiently equipped with both an industrial culture and technical know-how to engage in large-scale weapons production. This reassured Hitler further. This conviction turned out to be one of the most significant intelligence blunders in military history. However, there was an individual in America who doubted Roosevelt's assessment might actually hold true. His name was Charles Sorenson, a vice president at Ford Motor Company responsible for production. In 1940, when he was 60 years old, Sorenson had immigrated to the United States as a child from Denmark and spent his entire professional career with Ford. He played a crucial role in developing the moving assembly line at Henry Ford's Highland Park plant back in 1913. This innovation transformed manufacturing practices dramatically. Prior to Ford's method, automobiles were assembled individually by skilled craftsmen, much like aircraft were. The assembly line technique pioneered by Ford divided car construction into distinct tasks, carried out repeatedly by workers stationed along a conveyor belt. As the chassis moved past each station, every worker performed a specific task continuously. This process enabled unprecedented levels of mass production. By 1927, Ford had manufactured 15 million Model T cars using assembly line methods. Sorenson grasped an insight that eluded German analysts. The principles of mass production could be applied to any industry, including aviation. While it was accurate that American aircraft manufacturers constructed planes like craftsmen did, they were incorrect in assuming this approach was exclusive and unchangeable. Sorenson had seen firsthand how automobile manufacturing shifted from a craft-based process to an industrial-scale operation. He believed the same evolution could occur within the aviation industry. The challenge lay in whether anyone would give him the opportunity to demonstrate it. In January 1941, Sorenson journeyed to San Diego to meet with Consolidated Aircraft, the company behind the B-24 Liberator bomber. Accompanying him was Edsel Ford, Henry's son and the company president. They visited the integrated factory where workers were busy putting together B-24 bombers on the production floor. No blueprints were used, instead only rough sketches and templates guided their work. The assembly process involved measuring components by hand, fitting them manually, drilling precise holes, and filing edges to ensure a perfect fit. Each bomber was unique to its custom-made parts. The factory managed to produce one B-24 daily at most, which the management deemed impressive. However, Sorenson found this rate utterly unacceptable. He recognized what others overlooked. Each B-24 consisted of 200,000 individual pieces that could be standardized and manufactured using precision machinery. These parts could then be assembled in a sequential manner on a moving assembly line. The technology was already available. Ford employed it daily for car production, with a V8 engine featuring over 200 precisely machined components fitting together within incredibly tight tolerances. While the B-24 was larger and more intricate, its manufacturing process was not fundamentally different from that of an automobile. It presented an engineering challenge rather than an insurmountable obstacle. Later that evening, Sorenson pondered these insights in his hotel room at the Coronado. He understood the intricacies of large-scale manufacturing for complex machinery. A car engine consists of thousands of components that must interlock seamlessly. Although the AB-24 had even more parts, the fundamental approach remained identical: divide the product into smaller sub-assemblies, standardize each component, and develop equipment to produce uniform parts. Parallel assembly techniques were then employed before integrating everything on a conveyor belt system where the product progresses, not the workers. By 4:00 a.m., Sorenson had meticulously outlined his entire strategy on hotel stationery and placemat backs. At breakfast, he presented it to Edsel Ford. The plan envisioned a factory capable of churning out one B-24 bomber every hour. Reuben Fleet, Consolidated's CEO, examined Sorenson's sketches and dismissed the idea outright. He argued that aircraft manufacturing was fundamentally different from automobile production. Each B-24 weighed 35 tons with wings spanning 110 feet. Its engines alone tipped the scales at more than 1,000 pounds apiece. The notion of mass-producing bombers via assembly line seemed preposterous. Undeterred, Sorenson posed a straightforward inquiry to Fleet. Should Ford decide to manufacture B-24s, would you supply the necessary technical specifications and engineering assistance? Fleet agreed to do so on one condition: Ford would produce subcomponents destined for final assembly at Consolidated's facilities. However, Sorenson rejected this proposal outright, insisting that Ford either undertake complete production or abstain from involvement entirely. He argued that if Ford was committed, it must assume full responsibility for the manufacturing process using streamlined assembly techniques, otherwise there would be no collaboration. Despite believing Sorenson was bluffing, Fleet eventually accepted these terms. Certain that Ford would struggle to meet such stringent requirements, Sorenson returned to Michigan and successfully persuaded Henry Ford to construct a specialized facility dedicated solely to large-scale bomber production. This ambitious project resulted in the creation of Willow Run, an unprecedented industrial complex unlike any other previously established. Groundbreaking commenced on April 18, 1941, at a location situated approximately 35 miles west of Detroit near Ypsilanti, Michigan. Albert Kahn, renowned for his architectural designs of Ford's numerous facilities, including the expansive River Rouge plant, was entrusted with overseeing this groundbreaking construction project. Sorenson provided him with detailed specifications necessary to accommodate an entire bomber assembly line beneath a single roof. The building had to incorporate conveyor systems, machining equipment, ample storage areas for various components, and sufficient workspace for thousands of employees. Kahn devised an L-shaped layout spanning 3.5 million square feet, a groundbreaking achievement that far surpassed the dimensions of any previously constructed factory structure on a global scale. It marked the largest single-roof industrial building ever erected, setting new benchmarks in architectural engineering and manufacturing efficiency. The assembly line would stretch for a mile in length, featuring a 90-degree turn midway through. Accompanying this facility were an independent power station, a dedicated fire department, and an on-site hospital. Nearby, Ford constructed Willow Run Airport with 6 runways to enable bombers to undergo test flights shortly after production. The airport housed 3 hangars, one of which could accommodate up to 20 B-24 aircraft simultaneously. Additional amenities included a control tower, a cafe, and accommodations for test pilots. In today's currency, the entire project cost $800 million, while its original price tag was $47 million. The construction process was monumental in scale. A workforce of 300 men equipped with tools such as saws, axes, and bulldozers cleared a woodland area spanning 100 acres. This location had previously been Camp Willow Run, a Ford-owned property utilized for youth camping programs situated near Willow Run Creek, which inspired the facility's name. A steam-powered sawmill from Henry Ford's Greenfield Village Museum was used to convert fallen trees into 400,000 board feet of lumber needed for temporary structures. The building materials included 44,000 tons of structural steel, more than what was utilized in the construction of the Empire State Building. Additionally, over 1 million square feet of glass provided ample natural lighting throughout the facility. The concrete foundation required an amount sufficient to pave a highway stretching from Detroit to Chicago. The roof alone covered 78 acres, while workers installed approximately 500 miles of electrical wiring and 9 miles of conveyor systems. The plant featured its own water treatment facility and sewage system capable of serving a city of 50,000 residents. Ford invested an additional $20 million in tooling and equipment for the site. Among these were 7 500 machine tools, including colossal presses designed to stamp entire wing sections. Some machines weighed over 100 tons and necessitated specially built foundations. The magnitude of this undertaking was truly unparalleled. Willow Run was conceived with a singular objective: to churn out heavy bombers at an unprecedented scale that many deemed unattainable. In mid-1941, German intelligence gathered information about Willow Run through various channels. including trade publications and American newspapers which publicized the extensive construction efforts. Despite these reports, their evaluation remained largely unchanged. The factory might be vast in size, but Germany believed America would struggle due to a shortage of skilled workers, precise machinery, and the necessary organizational skills required for mass production. German Air Ministry estimates suggested Willow Run could produce no more than 200 bombers annually, with even fewer being probable. The dedication ceremony took place on October 22, 1941, featuring Major Jimmy Doolittle of the United States Army Air Forces, who would later lead a famous raid on Tokyo. Production commenced right away, with parts manufacturing starting that same month. However, during the first month, Willow Run produced no complete aircraft. The tally remained at zero in November and December as well. By January 1942, Willow Run had still not managed to produce any B-24 bombers despite 9 months of construction. Though the plant was operational, staff were present, and machinery was functioning, no finished planes emerged. The challenges faced by the factory were enormous. American newspapers started referring to it as Willow Run instead of Willow Run, a moniker that became an embarrassment for Ford. Congressional investigators visited the site and penned critical reports questioning if Ford's automotive expertise would suffice for aircraft production. In April 1942, Senator Harry Truman, who chaired the Senate Special Committee to investigate the National Defense Program, toured the facility and questioned whether Ford could successfully transition from building cars to manufacturing planes. The committee was investigating instances of waste and inefficiency in defense industries. Willow Run stood out as a notable case. Despite spending tens of millions of dollars, the facility had yet to produce even one combat-ready bomber. The issue lay in Ford's lack of experience with aircraft manufacturing. While the company did build the Ford Tri-motor transport plane in the 1920s, that was limited production of a much simpler design compared to the B-24. The complexity of the B-24 was significantly greater. Workers were unfamiliar with aluminum, which is softer and requires different handling techniques than steel, their usual material. Automotive workers were accustomed to working with harder steel, which could withstand rougher treatment. Aluminum demanded specialized tools, training, and methods that differed greatly from those used in car manufacturing. Aircraft components had tighter tolerances compared to automotive parts. Any imperfections would affect aerodynamics and structural integrity. Tools designed for stamping car parts caused damage when applied to the softer aluminum sheets used in aircraft construction. Dies optimized for steel often failed with aluminum, leading to Sorenson needing to redesign and rebuild thousands of tools at a substantial financial cost. Millions of dollars worth of tooling was scrapped and replaced. Frequent design changes from the military further disrupted production, necessitating constant retooling. In just the first year alone, 575 engineering modifications were ordered, each requiring adjustments to tooling jigs, fixtures, and assembly procedures, often causing delays across multiple sub-assemblies. The B-24 bomber was far more intricate than a car, with approximately 1.2 million yen parts compared to around 15,000 in an automobile. The sheer scale and complexity of managing such a vast number of components were daunting. Each part had to be meticulously manufactured, inspected, stored, tracked, and delivered to the assembly line at the precise moment it was needed. A missing component could halt production altogether, but Sorenson pressed on with determination. He reorganized workflows, trained workers in new methods, redesigned tools, and divided the B-24 into 11 major assemblies and 69 sub-assemblies. Each of these sub-assemblies was built separately along its own production line before being delivered to the final assembly sequence. The center wing section became the central hub of the manufacturing process. All pre-fabricated parts were made to exact specifications so they would fit together without requiring custom adjustments. A multi-function machine completed 42 precise machining operations on components with a tolerance of 0.001 inches in just 17 minutes. The shift from craft production to mass production necessitated retraining the entire workforce. Ford set up an aircraft apprentice school at Willow Run, where as many as 8,000 students were trained each week. Classes ran continuously, and workers learned skills such as riveting sheet metal work, electrical systems, hydraulics, and quality control. The training was rigorous due to the higher standards required for aviation compared to automotive production. A faulty weld on a car frame might be unacceptable, but a defective weld on an aircraft could lead to catastrophic failure during flight. Workers took this responsibility seriously because they understood that pilots' lives depended on their work. In September 1942, the first completed B-24 emerged from Willow Run. The journey from the factory's inauguration to the rollout of the first aircraft took 11 months. A ceremony was held to name this inaugural plane the Spirit of Ypsilanti, which attracted local officials and media attention. However, that particular bomber never saw combat duty, neither did the subsequent 55 aircraft. Instead, they served as training vehicles and transports due to insufficient quality for frontline operations. Inspections by Army Air Forces personnel uncovered numerous defects, unfinished work, and discrepancies from established specifications. Critics were vocal about the project's perceived failure. A congressional committee report highlighted Ford's attempt to manufacture bombers akin to automobiles despite warnings from seasoned aircraft manufacturers. This assessment was accurate nonetheless. Sorenson pressed on undeterred. He transformed the rejected bombers into educational resources for workers, meticulously dissecting every flaw and utilizing each issue as a learning opportunity. As a result, quality gradually improved with each successive aircraft. By January 1943, Willow Run had produced 31 bombers that met Army Air Forces standards. The following months saw an upward trend in production numbers: 59 in February, 75 in March, 104 in April, and 130 in May. Month after month, output continued to rise as employees gained proficiency in their roles, and continuous improvements were made to processes and tools through the identification and resolution of issues by engineers. By June 1943, Willow Run was churning out 190 bombers per month, which surpassed twice the output of Consolidated's initial San Diego factory. This rate continued to rise. The turning point occurred when Ford managed to integrate all 11 major assembly lines into a cohesive production system. Wings were constructed on dedicated parallel tracks. Fuselages proceeded through their own assembly process, and engines from Pratt & Whitney arrived at a separate area for preparation. Gun turrets, supplied by subcontractors, underwent testing before being installed. Each component seamlessly converged at the main assembly line in perfect order. In April 1944, Willow Run manufactured 453 B-4 bombers within 468 working hours, equating to more than 1 bomber per hour. This achievement was a direct fulfillment of Sorenson's promise made 3 years prior when Reuben Fleet dismissed his hotel room sketches with laughter. The factory operated around the clock in 3 shifts, completing a new bomber every 63 minutes on average. The final assembly line moved at a steady pace of approximately 100 feet per hour as workers installed engines, mounted wings, fitted gun turrets, connected hydraulic systems, and installed electronics. As each aircraft passed by their stations, employees executed specific tasks within designated time frames, ensuring precision in the choreography. During peak production, Willow Run employed 42,000 people, making it an exceptionally diverse workplace for its time in America. Most workers had little to no experience building anything more intricate than a car prior to joining. Notably, women made up 65% of the workforce, many of whom were new to industrial jobs due to the war effort. Despite facing discrimination in both hiring and housing African American workers accounted for roughly 10% of the workforce. The age range of these employees spanned from 18-year-olds to those who were in their 60s. They hailed from a variety of backgrounds, including agriculture, retail work, and domestic employment. Ford actively recruited and trained these individuals due to the significant number of skilled industrial workers being drafted into military service. Many workers commuted long distances from Detroit on dedicated shuttle buses because there was insufficient housing close to the plant. Each day's round trip exceeded an hour, navigating often crowded roads. To address this transportation issue, Ford established 165 private bus routes that ferried employees to and from work. In addition, public transit expanded its offerings by adding another 35 routes. The logistics involved in moving around 42,000 people daily were considerable for a rural location. To accommodate the influx of workers and their families, the federal government constructed an entire residential community right next to Willow Run. This new settlement, known as Bomber City, reached its peak population of 13,000 residents. It featured temporary housing units, educational facilities catering to both adults and children, retail spaces selling essential goods, medical services staffed by healthcare professionals, and recreational areas such as playgrounds and sports fields. Bomber City was essentially a small town designed exclusively to support aircraft manufacturing operations. The federal government also accelerated the construction of the Willow Run Expressway, one of America's earliest limited-access highways, aimed at easing worker transportation from Detroit. This expressway opened in September 1942, promptly alleviating traffic congestion. During wartime, infrastructure projects that typically required decades to plan and build were completed within months. By the close of 1944, Willow Run had manufactured over 5,000 B-24 bombers, surpassing Japan's total aircraft production for the same year, which amounted to approximately 28,000 planes across all types. Willow Run wasn't the sole factory revolutionizing American aircraft production. Boeing in Seattle manufactured B-17 Flying Fortresses on assembly lines employing techniques akin to those used at Willow Run. At its Plant 2, Boeing employed a workforce of 35,000 and reached a peak output of 350 B-17s per month. This facility operated with the same tireless efficiency that Ford exhibited in bomber production. In Long Beach, Douglas Aircraft was mass-producing C-47 transport planes, which became indispensable for Allied logistics. The military version of the DC-3 commercial airliner, the C-47 required precise manufacturing despite being simpler than a bomber. During the war, Douglas produced more than 10,000 C-47s. North American Aviation was building P-51 Mustang fighters at facilities in California and Texas. The P-51 emerged as arguably the finest fighter aircraft of World War II, outperforming anything Germany or Japan could produce. North American manufactured over 15,000 Mustangs using advanced assembly line methods. In Fort Worth and San Diego, Consolidated was producing B-24 bombers with adapted assembly line techniques learned from Ford. By the end of the war, Fort Worth had assembled approximately 3,000 B-24s. Lockheed built P-38 Lightning fighters at its factories, a distinctive twin-boom fighter that saw action in all theaters of the conflict. Over 10,000 P-38s were produced by Lockheed during World War II. Martin was responsible for building B-26 Marauders, medium bombers extensively used in both Europe and the Pacific Theater. Republic Aviation manufactured P-47 Thunderbolts, heavy fighters that excelled in ground attack missions. Republic built more than 15,000 P-47s during the war. Grumman produced F-6F Hellcats for the Navy, carrier-based fighters that dominated air combat over the Pacific. Over 12,000 Hellcats were manufactured by Grumman. Vought was responsible for building F-4U Corsairs, another legendary naval fighter renowned for its exceptional performance. All major American aircraft manufacturers had transitioned to assembly line production within just 3 years. Small companies, which typically produced dozens of planes annually during peacetime, were now churning out hundreds each month. The automotive industry played a crucial role beyond Ford's Willow Run facility. General Motors alone contributed over $10 billion worth of war materials encompassing aircraft engines, gun turrets, and complete aircraft. Chrysler was responsible for manufacturing tanks as well as fuselage sections and other components. Nash Kelvinator, famous for its refrigerators, also joined the effort by producing aircraft propellers and engines. The entire industrial sector had been retooled for wartime production. In 1941, American aircraft factories employed 159,000 workers and produced 1930 planes. By 1942, Employment surged to 2 million workers with a production output of 47 A380 aircraft, more than double the previous year's total. In 1943, this number nearly doubled once again, reaching A5, A9 aircraft. In 1944, American factories churned out an impressive 380 military planes, surpassing President Roosevelt's initial target of 50,000 per year by nearly double. During this period, aircraft design and performance also saw significant advancements. The B-7 the bomber went through numerous iterations labeled A through G, each upgrade enhancing its defensive armament, engine power, range, and payload capacity. By the time the final G model was introduced, it boasted 1350 caliber machine guns for defense, far more than earlier versions. Similarly, the B-24 received continuous improvements to its engines, defensive weaponry, and systems throughout its production cycle, with over a dozen variants developed. The P-51 Mustang, which entered service in 1943, was vastly superior to any aircraft flying in 1941, boasting a range that enabled it to escort bombers all the way to Berlin and back. A pivotal development that revolutionized the strategic bombing campaign. Early combat aircraft had limited ranges, often no more than a few hundred miles. In contrast, the P-51 could fly well over 500 miles. This enabled U.S. bombers to penetrate deep into Germany with fighter escort for their entire mission, ensuring greater safety and efficiency. Prior to the introduction of the P-51, American bombers had to undertake missions without fighter protection, resulting in substantial losses. With Mustangs providing cover, bomber casualties declined sharply while German fighter squadrons faced heavier attrition. Beyond merely manufacturing aircraft, U.S. factories were churning out superior models at an unprecedented rate. From 1940 to 1945, the total output of military aircraft exceeded 300,000 units. This figure encompassed a wide range of types, including trainers for pilot training, transports for cargo and personnel movement, fighters for air superiority and ground support, bombers for strategic and tactical operations, and reconnaissance planes for intelligence gathering. During World War II, the United States produced more military aircraft than all other countries combined. Britain's of 130,000, Germany is 120,000, the Soviet Union's over 150,000 despite significant wartime industrial disruption, Japan has 76,000, and Italy sent about 11,000 before switching alliances in 1943. The Axis powers collectively manufactured approximately 207,000 aircraft. Allied production surpassed 600,000 units, with the US accounting for roughly half of that total at around 300,000 aircraft. Early in 1943, German military intelligence noticed an anomaly. Reports indicated a much larger number of American bomber formations over Germany than previously expected. Numerous aircraft swarmed the skies as American bombers appeared in formations ranging from 300 to 500 planes at a time. German fighter pilots encountered endless waves of B-17 and B-24 bombers, accompanied by numerous P-47 and P-51 escorts. Despite shooting down several American bombers each day, more would appear the following morning. It seemed as though the United States had an inexhaustible supply of aircraft. Initially, Luftwaffe Commander Hermann Göring dismissed these reports as mere exaggerations, a common occurrence during combat when pilots tend to overestimate enemy numbers. However, the consistent flow of reports suggested otherwise. By mid-1943, it was evident that the United States had launched bombing campaigns on an unprecedented scale. The 8th Air Force, based in England, conducted daylight raids using formations that sometimes surpassed 1,000 aircraft when fighter escorts were included. The sheer volume of these operations was overwhelming. On a mission in October 1943, the 8th Air Force dispatched 291 B-17 bombers to attack Schweinfurt's ball-bearing factories. Despite losing 60 planes during this raid, American forces returned 2 days later with an equally formidable formation. This level of industrial warfare was beyond Germany's capacity to counter. The efficiency of the American replacement system ensured that lost bombers were quickly replaced within a week and crews were replenished within a month, allowing bomber units to maintain their operational strength despite significant losses. Albert Speer, Hitler's Minister of Armaments and War Production, reviewed German intelligence assessments of U.S. industrial output. The figures he encountered were staggering. American aircraft production in 1943 was more than 3 times that of Germany's. American tank production exceeded Germany's output by a factor of 2. The United States was constructing cargo ships at a rate of 1 per day. Speer came to understand that German officials had profoundly underestimated American industrial capabilities. In his post-war book, Inside the Third Reich, Speer discussed how German leadership disregarded accurate intelligence regarding American manufacturing prowess. Hitler dismissed reports from German observers stationed in America, insisting that claims about American production were mere propaganda and that superior German quality would triumph over quantity. By 1943, Speer was convinced that this view was gravely mistaken. While Germany produced high-quality weapons, the volume was insufficient to sustain the war effort. In contrast, the United States manufactured a vast number of good, quality weapons. In industrial warfare, sheer numbers often outweighed minor quality advantages. By 1944, American industry had surpassed the total war output of all Axis powers combined by a margin of 2, despite controlling most of Europe's industrial resources and employing millions of forced laborers while operating factories around the clock. Germany could not match American production levels. German fighter pilot Adolf Galland commanded Luftwaffe forces from November 1941 to January 1945. He observed firsthand the transformation in American air power. In 1942, Galland's fighters dominated European skies. The Luftwaffe had superior aircraft, better training, and more combat experience than their American counterparts. German pilots shot down American bombers at rates that seemed unsustainable for the Americans. Nevertheless, the United States kept deploying an endless supply of new planes and crews. By mid-1943, this dynamic had completely reversed. American fighter planes appeared in staggering numbers. Even when German pilots enjoyed tactical advantages, they were outnumbered by a ratio of 5-to-1 or even 10-to-1. Despite Galland's pilots being able to shoot down American fighters, more would arrive the following day. The Americans did not appear to mind their losses. They had such an abundance of aircraft that attrition was manageable. One German pilot likened it to trying to hold back an avalanche. Individual bombers and fighters could be stopped or destroyed, but the sheer mass kept coming daily for weeks on end. In late 1944, Galland reported to Hitler that German fighter forces were being overwhelmed not by superior tactics or better aircraft, but by overwhelming numbers. The Americans were producing more planes than Germany could destroy. Galland requested permission to redeploy fighters from the Eastern Front to defend German cities, but Hitler refused, still clinging to the belief that victory could be achieved through technological superiority and sheer willpower. By 1945, Galland was flying missions with an experimental jet fighter unit because conventional piston engine fighters were no match for the mass of American aircraft dominating European skies. In December 1944, Germany launched the Ardennes Offensive, also known as the Battle of the Bulge. The initial surprise and significant territorial gains quickly dissipated within 3 days when overwhelming American air power descended upon them. Overcast weather had grounded Allied planes at first, but this was a deliberate strategy on their part. German strategists deliberately selected this period, knowing that clear skies would give the Americans an overwhelming advantage in the air. By December 23rd, the weather had improved significantly. This change allowed American aircraft to showcase their formidable production capabilities. Hundreds of P-47 Thunderbolts and P-38 Lightning fighters engaged German ground forces, while squadrons of B-26 Marauder medium bombers targeted enemy supply lines. Heavy bombers from the 8th Air Force also shifted their focus from strategic targets to striking German communication hubs and railway facilities. Between December 23rd and January 16th, Allied air forces conducted more than 74,000 sorties and dropped over 11,000 tons of explosives. They destroyed 11 378 transport vehicles, 1,061 tanks and armored units, 57 locomotives, 6 266 rail cars, and 472 artillery positions. German troops in the Ardennes were overwhelmed by the sheer volume of American air power. The sky was filled with Allied aircraft, leading one German officer to later describe it as a scene from an industrial nightmare. Everywhere there were American planes. They controlled the airspace entirely. Although German anti-aircraft guns managed to shoot down some aircraft, more reinforcements arrived almost instantly. The Germans lacked any effective response strategy. A research paper at the Air Command and Staff College concluded that this was the first instance where air power had successfully halted a major counteroffensive. The German advance rate of 20 kilometers per day persisted until December 23rd, but slowed on December 24th, coming to a complete halt by December 25th. This timing coincided perfectly with deployment of American air assets. The failure of the Ardennes offensive was largely due to the destruction of German supply columns and the trapping of their forces in deadly zones caused by relentless aerial bombardment. This overwhelming air power originated from factories such as Willow Run. By January 1945, the Luftwaffe had become an ineffective fighting force. Germany still possessed fighters and pilots, but fuel shortages, heavy pilot losses, and a significant numerical disadvantage meant that German aircraft rarely contested American air supremacy. American bomber squadrons could fly over Germany during daylight hours with minimal risk. Fighter escort patrolled German airspace, seeking out targets to engage. Strategic bombing missions systematically targeted German factories, rail lines, oil refineries, and transportation networks from the sky. This devastating campaign was facilitated by substantial American aircraft production at numerous sites, including Willow Run in Michigan, Seattle, Long Beach, and other locations. The sheer volume of bombers lost could be rapidly replaced. New crews were continuously trained in American flight schools to compensate for pilot losses. In contrast, Germany could not match this replacement rate. Once American wartime aircraft manufacturing ceased in August 1945, the total number of military aircraft produced reached 300,000, with 37,000 being B-24s from various factories. Willow Run alone assembled 8 6-85 B-24s, including 1 893 knockdown kits shipped to other plants for final assembly. The last B-24 rolled off the line at Willow Run on June 28, 1945. By then, Charles Sorenson had left Ford after being ousted in a power struggle with Henry Ford on March 30, 1944, just as production peaked. He subsequently went to work for Willys Overland and never returned to Ford. Throughout the war, Sorenson received no official recognition for his contributions to Willow Run. No medal, commendation, or public acknowledgement. The accomplishment at Willow Run was largely credited to America's industrial prowess and Ford Motor Company, yet Sorenson's contributions remained relatively unacknowledged in official records. William Knudsen, who had been concerned about the feasibility of Roosevelt's targets when he worked in Detroit in May 1940, became Commissioner of Industrial Production at the National Defense Advisory Commission on May 28, 1940. Over the next 2 years, he oversaw the mobilization of American industry across the entire economy. In January 1942, Knudsen was commissioned as a lieutenant general in the United States Army, becoming the sole individual in U.S. history to enter military service at 3-star rank without prior experience. He continued to collaborate with the War Department until 1945, organizing the production of tanks, trucks, weapons, ammunition, and aircraft. Post-war, he resumed his career in private industry. Knudsen later declared that American victory in World War II was determined by factory output rather than battlefield achievements. The side capable of manufacturing more weaponry, ammunition, aircraft, and tanks would emerge victorious. Everything else was merely tactical maneuvers. Knudsen believed that American industry not only defeated the Axis powers, but also overwhelmed them with an avalanche of production they could never match. His evaluation proved accurate. Roosevelt's term "arsenal of democracy," introduced in a December 1940 radio address, was not mere rhetoric but literal truth. American factories produced 64% of all Allied military equipment utilized during World War II. By 1944, the United States surpassed all other nations, its own allies included, in war material production. Hitler witnessed the repercussions of his strategic misjudgment by April 1945, when Soviet forces were battling in Berlin streets while American and British troops controlled Western Germany. German cities were devastated from Allied strategic bombing campaigns. The Third Reich was disintegrating, with its last days spent inside the bunker where Hitler resided. In these final moments, he criticized his generals, accused traitors, and blamed everyone but himself and his advisors who had dismissed American industrial capabilities as mere propaganda in 1940. These advisors had assured him that Roosevelt's claim of producing 50,000 aircraft annually was impossible. They were confident that the United States could not mobilize for total war. They convinced Hitler that Germany would triumph before America managed to manufacture sufficient weaponry to be a threat. However, they turned out to be incorrect on every count. By May 1940, producing 50,000 aircraft annually had been deemed impossible, yet by 1944 this figure was surpassed. In that single year alone, American factories manufactured 96,000 aircraft, and over 5 years, the total production reached 300,000 planes. The Germans had initially called these projections propaganda, but the United States proceeded to build those planes nonetheless, ultimately delivering a decisive blow from the air against the Third Reich. Albert Speer survived the war and spent 2 decades in Spandau prison as a convicted war criminal. In his memoir penned during incarceration, he reflected on Germany's strategic blunders. He emphasized that underestimating American industrial power was their most significant mistake. German leaders had observed America's small peacetime military force and concluded that it rendered the nation weak. They overlooked America's extensive industrial base, advanced engineering expertise, tradition of mass production innovation, and swift capacity for mobilization. Speer calculated that by 1944, a single American factory like Willow Run was producing more aircraft per month than entire German industrial regions combined. He asserted that Hitler's decision to declare war on the United States in December 1941 marked the moment Germany lost World War II. Not due to America's military prowess at that time, since the country barely had an army then, but because declaring war guaranteed full mobilization of American industrial capacity against Germany. Once this formidable power was unleashed, Germany could no longer compete effectively. If German intelligence had accurately assessed American industrial potential in 1940, Hitler might have made different strategic choices. German analysts examined American aircraft production figures for 1939 and noted the output was less than 3,000 planes. They incorrectly assumed this level represented America's full manufacturing potential. In reality, American industry had not yet attempted to produce aircraft on a large scale due to limitations imposed by major military budgets and small orders rather than industrial constraints. Once mass production techniques, honed in the automotive, shipbuilding and machinery industries were applied to aircraft manufacturing, output skyrocketed. Over a 4-year period, production grew twofold. The total American aircraft production during World War II amounted to an astounding 300,000 military planes from 1940 through 1945, a figure hard to grasp because of its enormity. If lined up wingtip to wingtip, the planes would stretch twice across the United States, from New York to Los Angeles and back. Stacked one atop another, they would reach into outer space. The cumulative weight of these aircraft was over 6 billion pounds of materials such as aluminum, steel, rubber, and electronics. Production also required 150 million board feet of lumber for packaging and shipping. It used 2 billion rivets and enough electrical wiring to encircle the Earth 40 times. At peak production in 1943, over 2 million workers were employed across factories totaling more than 100 million square feet in floor space. These facilities consumed as much electricity as the entire city of Detroit and utilized raw materials from every state and numerous countries. American industry managed to build out supply chains, train staff, design tools, and resolve production challenges within a span of 4 years. From President Roosevelt's speech in May 1940 to peak production in 1944, exactly 4 years had passed during which aircraft output increased from fewer than 3,000 planes annually to an astonishing 96 318 planes in 1944 alone, a staggering 32-fold increase. No other industry effort throughout history has equaled the scale and speed achieved during World War II. When examining how the Allies triumphed, historians often highlight pivotal battles such as D-Day Midway, Stalingrad, and the Battle of Britain. However, these victories would not have been possible without the massive production capabilities from factories across the United States. The B-24 bombers that targeted German industry were manufactured at Willow Run, while P-51 Mustang fighters, which protected those bombers, came off assembly lines in California and Texas. C-47 transport planes used to deploy paratroopers during Operation Overlord were built by Douglas Aircraft Company in Long Beach. Liberty ships, crucial for transporting supplies across the Atlantic, emerged from shipyards employing assembly line techniques adapted from aircraft production methods. Every weapon, vehicle, and ammunition was crafted in American factories. The bravery of soldiers, sailors, and airmen who utilized these resources cannot be overstated, nor can the skill of strategists like generals who planned operations. Yet, without an abundant supply chain provided by industry, such courage and tactical acumen would have fallen short. Both Germany and Japan possessed courageous troops and capable commanders, but ultimately succumbed because they could not match Allied industrial output. American manufacturing prowess ensured a decisive Allied victory once the production lines were maximized. At this point, Axis forces found themselves in an unwinnable conflict. The defeat was merely a matter of time. The narrative of America's accomplishment in producing 300,000 aircraft over 4 years encompasses more than military history. It illustrates industrial might, engineering prowess, innovation, organizational efficiency, and national mobilization. It tells the story of Charles Sorenson working tirelessly through the night in a San Diego hotel, sketching bomber assembly line designs on placemats because he understood that mass production was feasible. At Willow Run, approximately 42,000 workers, mostly women who had no previous manufacturing experience, were producing 1 bomber per hour across 3 shifts daily. This feat was made possible by Albert Kahn's design of the largest factory ever constructed at that time, housing a mile-long assembly line. William Knudsen orchestrated industrial mobilization efforts in thousands of factories spread across 48 states. Meanwhile, Roosevelt set ambitious production goals that seemed unattainable, but American industry managed to meet them. In 1939, German intelligence analysts dismissed Roosevelt's speeches as propaganda when they looked at the initial American production numbers. However, this assumption was flawed. The Germans failed to recognize that American industry had yet to test its full capacity for aircraft manufacturing. They also underestimated the potential of assembly line mass production methods in this sector and did not foresee factories like Willow Run coming into existence. By the time German leaders realized their mistake, it was too late. The American industrial machine was already fully mobilized and outproducing Germany's war efforts. This demonstrates that during World War II, industrial capacity played a more crucial role than tactics. Production efficiency determined victory on the battlefield. In fact, American industry alone surpassed the combined production of the rest of the world. From fewer than 3,000 aircraft produced in 1939, the United States ramped up to over 96,000 by 1944 within a span of 4 years. Despite initial skepticism from German analysts who believed it was merely propaganda, America's manufacturing capabilities proved them wrong. If you found this story intriguing, please like and share to help us uncover more forgotten histories from World War II. Subscribe for more untold stories and leave a comment telling us where you are watching from. The global reach of our community ensures that each viewer contributes to preserving these historical records. Your participation in viewing is greatly appreciated.